Hello, good day. Well, for today we are going to check something related about the precalculus. The name of this topic is interval notation. And well, what is the idea about this? Let's gonna start with the idea about what is an interval. Interval is a group of elements that you can take, okay? Normally we can talk about, for example, the elements that you can take from the x, okay, or the elements that you can take from the y, okay? For example, when we have a function here, we have the function of x equal 1 over x plus 5. Here we need to identify, for example, what values from the x is possible to take just to make that this function exist, okay, or just to make this function make it real or make it possible. So, for example, here if we have a fraction, we need to remember when we have a fraction, we need to avoid, for example, we have a over b, we need to avoid that the denominator it's not b equals 0, because when we have in the denominator the value of 0, the function is undefined, okay, or it's not possible to calculate. So we need to find from the denominator what values, in this case, for example, from the variable of the x, in this case, create the 0, okay, because if we have values from the x and create the 0, we need to avoid these values. So for example, the way to find this is gonna be like a x plus 5, it's gonna be equal 0, okay. We need to find values from the x and create the 0. So we need to solve this equation, x plus 5 equals 0. So when we solve, it's gonna be simple. We move the plus 5 until the other side, or we subtract minus 5 minus 5. We cancel the 5 here, and we conclude when x is equal minus 5, the denominator is going to be 0. Just then you can understand better. For example, in my turn, I put 5, well, minus 5 plus 5. We're going to have 1 over 0, and this is not correct. Okay, so undefine the, well, let's say not possible. Okay. So here, this is the idea. We need to identify what values from the x is gonna be, or we're gonna create the 0. So, for example, let's gonna say that we identify, or we already found the value of the x and transform this function in undefined. It's minus 5. Let's gonna say that the minus 5 is here, and let's gonna be focused here. For example, only the axis x. Okay, and the axis of x, if we have this expression, imagine that we can take all the values from the left. We are going to move from left to right, okay, until this point. And here I'm going to represent this point like, or with a hole, okay. We put the hole here and we can continue with this situation. So, for example, here, we can say that is well, we have a hole, and the hole is not proper from the minus 5, okay? It's not possible to take. So this is the idea, okay? Analyze only the axis of x. This arrow represents, let's gonna say, the minus infinite. Minus infinite is all the negative values from the x, okay? This section represents the positive infinite. In other words, all the positive values from the x. So the idea here is, if we want to create, or we want to express this with an interval, just to express what are the values that we can take, we can start from minus infinite until minus 5, and we're going to put the parentheses. We are going to talk a little about the parentheses, but this minus infinite until minus 5, and we are going to continue from minus 5 until positive infinite, and we're going to represent this with parentheses, okay, and we can express this with a u that represent this the union. This parentheses, what is the meaning about the parentheses? Well, the parentheses means like we can't take this value, okay. For example, when you arrive until minus 5, you can approach as much as you can, okay. I don't know, like a minus 0.9999, but it's not going to be 5. Okay, so we represent this and we approach as much as we can until minus 5. We don't take this value, okay? Or we say that this is open interval because we use the parentheses, okay? is open because we don't take this value. So this is one way that we can express the intervals, okay? From minus infinite until minus 5, the union symbol, and we have minus 5 until positive infinite, okay? And we represent the same with the parentheses, because also, for example, here, what happened with the infinite? We don't know what is the exact value, okay, about the infinite. So we represent with parentheses, okay, because we can't take the infinite, okay? We can only approach, but it's not possible to take exactly this value. So this is the way that we can express this. Now, for example, what about with another situation? Then we need to use the intervals. For example, what about the square root? The function of the radical function, okay, or the function of a square root. So here, let's go to imagine that we have one function that is x minus 9. And here, remember, when we talk about the square roots, it's not possible to have negative values into the square root, okay? We need to avoid any negative value. So how can we represent this? Now, we don't use the equation, okay? We're gonna use an inequality. We need to use the symbols less or 10 tan or greater than. In this case, because we are very specific and we don't require the negative values into the square root, we can express like this. We have x minus 9 is greater or equal 0. This symbol represents that we're going to take only positive values, okay? It's going to be greater or equal 0. Imagine that we have the 0 here, and we can have the value of 0, or we can continue, okay? Only until positive values. So for this situation, we can solve it in this way. Just let me show you here. It's going to be like a function of x is going to be, wait, not function of x, sorry. Here, it's going to take this inequality, and we are going to have x minus 9 greater or equal 0. So we are going to add plus 0 plus 0. We can cancel this, and it's going to be x greater or equal 9. Okay? So what is the idea about this? The idea about this is that we can take, and I'm going to write only the axis of x, okay? Here, the idea, imagine that we have the 0, okay? We have the 0 here, and we can take only from 9 until the infinite, okay? Here, when we can take the value, we can represent this with a dot, okay? It's not a whole, it's a dot, because we can take this value. Check this symbol, okay? Say it, and we can take the 9, but also all the values greater than 9, okay? So the way to represent this is with a bracket, okay? Because we can take the 9. It's going to be bracket positive 9 slash and infinite. And the infinite we can represent only with the open symbol, okay? So this is the infinite. This is the way that we can represent the interval. So this is the way that we can use the interval notation. If you express, for example, or if you just want to verify the situation, imagine that we say that is x greater than 9. Let's gonna say that we don't take the 9, okay? We take one value less than 9, for example, the 8, okay? So if we apply the substitution, if we say like x is equals 8, imagine this. The function when the x is equals 8, or evaluate in 8, we have 8 minus 9 is going to be like a square root of 8 minus 9 is going to be negative 1. It is not possible, and you can check this into the calculator. You just try to put a negative value into the square root. It's not possible to calculate this, okay? So that's the reason, for example, if we put the 9 or greater than 9, for example, the 10, that's going to say 10, okay? If we say the square root of 10 minus 9, well, here the result is going to be a square root of 1. That's possible to calculate, okay? Square root of 1 is 1, okay? So this is the idea that you need to understand. And here is when we talk about the intervals notation, okay? Here, because we are very specific about we are talking about the x, well, let's gonna say that this is the domain. Why? And this is one of the definitions. All the values from the x, or all the values from the independent variable, we talk about the domain. Okay, the domain here is square root of 9. Well, sorry, square root of 9, bracket 9, and infinite. Okay, so this is the way that we can express the domain. Okay, for the range, well, for the range is it's gonna be a little different. Okay, it's because we need to analyze another concepts also into the graph, like asymptotes and something like that. But here I only want to be focused about how can you express the intervals, okay, or what is the interval notation. So, well, I hope that you understand, and if you have any comment or question, you can put that on the button here in the comment section. And well, that's gonna stop here. See you.